Coming up on this edition of The Climate Show, it's all news and we've got plenty of it, including the wetter parts getting wetter and the drier parts getting drier. Also, Gareth?
We've got warm water, melting ice in Antarctica, Pacific Islands acting as refuges for corals in a warming climate.
And John Cook is along, plus we've got the solutions. It's all in there coming up on this edition of The Climate Show. This episode of The Climate Show is brought to you by hot-topic.co.nz, cyblogs.co.nz, skepticalscience.com, scoop.co.nz, idealog.co.nz, and Kiwi FM.
What good is a drop in the ocean? What good is a drop in the ocean?
Welcome to The Climate Show, episode number 26, recording 2nd of May 2012. This is the show that digs through all kinds of climate change matters, from the politics, the solutions, the science, the skeptics, the scoundrels, and everything else in between. Talking about scoundrels, my co-host is Gareth Ronalden in North Waipara in Canterbury. North Canterbury, Waipara. Hello, Gareth.
Hi, Glenn. It's going really well today, I can tell.
Yes, it just. And of course, I'm Glenn Williams, recording in Auckland, New Zealand, in the North Island. And good to be back in the Climate Show seat as well, because it's been a few weeks. Apologies for the absence, but you know, life tends to get in the way of things sometimes.
Yeah, life, the universe, and in my case, grapes and truffles get in the way occasionally of recording shows.
Yeah.
But yeah, so it's been a busy month for me, and I'm sure it has been for you too, Glenn. But that means that we've actually got quite a lot of news coverage to get through.
Stack.
So let's crack on, shall we?
Yes, we will. And just before we do, remind you that you can get the show in two flavours, audio and video. You'll find the video in YouTube form. It's up at theclimateshow.com and hot-topic.co.nz, where you'll find also the links to subscribe to the audio, so you get that automatically as well. And even on Stitcher.com or the Stitcher app on your smartphone, your Android phone, your iPhone, which is a very cool way to listen to radio and podcasts as well. But so let's roll on into the news. First up, news that the World Meteorological Association or organisation has confirmed that 2011 was the 11th warmest in the long-term record. Any surprises there, Gareth?
No, not really. I included this item at the head of the news really because of one of the statements in the WMO press release. This was issued just after we recorded the last show, and the statement was it really made me kind of sit up, because what the WMO said was that the decade from 2001 to 2010 was the warmest decade ever recorded for global land surface, sea surface, and for every continent. In other words, beyond any shadow of a doubt, the last 10 years have been the hottest in recorded history, which is, in WMO terms anyway, since 1850.
Yeah.
And therefore we know from the paleoclimate work that likely that last decade was the warmest in at least a couple of thousand years. And quite possibly, although the uncertainty gets greater the further back you go, quite possibly the warmest since the end of the last ice age, which is something else we're going to talk about later on. Yeah. But yeah, the WMO are actually going to be releasing a full report on the first decade of the 21st century, which will dig down into all of that details. It's not been released yet, but their summary for 2011 gave us a few hints of what was going on. And they talk about global warming having accelerated over the last decade. No hint of any sort of pause in global warming. Maybe hint of a hiccup, if you like, in the steady progression of global average surface temperature. But that doesn't mean that warming has stopped by any stretch of the imagination. So yeah, I wanted to put that at the top of the news because of that remarkable statement. Really,
we've got these graphs from the report as well, showing the temperature changes with respect to the long-term average.
Yeah, that first graph you're showing now, it compares the Hadley Series 3 temperature record for the first decade of the 21st century, with the 1961 to 90 30-year average. And as you can see, most of the northern hemisphere, and certainly over land, is showing itself as being between 1 and 3 degrees Celsius above average, virtually everywhere in the northern hemisphere, with 1 or 2 small exceptions.
Gosh, it really is the northern hemisphere, isn't it, as opposed to the southern hemisphere?
Yeah, absolutely. I mean, the southern hemisphere is mostly ocean, and that has always been expected to warm more slowly than the rest of the world, simply because there's a lot of water, that it takes a lot of heat to keep it going. But, you know, there are hotspots in the southern hemisphere. You're looking at Central Australia, looking at southern Africa, you're looking over Brazil. You're looking actually in a big hotspot in the middle of the South Pacific Ocean to the east of New Zealand. And you're looking at the Tasman between New Zealand and Australia, also having warmed with respect to the 61 to 90 average. So, yeah, quite dramatic. And in fact, that reminds me of a series of graphs from one of Hansen's recent publications, where he's looked at the effect of the changes in long-term averages on heat waves and seasonal temperatures, and they're very reminiscent. And you know, when you look at a picture like this, which is climatologically based, you can see very clearly that the warming, first of all, has occurred, but is continuing. And if you flick down on that WMO graphic to the second page, Glenn, you'll see they've got the going back to the decade 1881 to 1890. Yeah. And so if you look at if you take the full 120, 130 year record, there's a trend there, which is a reasonably steep increase over the period. And then you look at what's happened over the last 40 years, and you can see that rate has really steepened up quite a lot.
Because this is, I mean, it's undeniable stuff, you know, that you're looking at graphs like that. I mean, that's just a very steep increase there from what, about the 1960s?
Yeah, absolutely. But, you know, you and I might think it's undeniable, and you know, most rational people might regard it as undeniable. But you will find out there in skeptic land that people will argue, first of all, if they can't argue with the fact that it's warmer now than it was more in the recent past, then they'll say, well, maybe you can't trust the thermometers, maybe you can only trust some things. And funnily enough, those some things usually turn out to show less warming than the normal thermometers. All those
broken thermometers around the world, you know, so it's all their fault.
Yeah, well, apparently they're all located next to central heating and air conditioning outlets, and you know, they've all been fiddled with. And then you get people who will say, yes, but it's going to cool very soon. You know, of course it's warm. We're at the peak of a cycle. The trouble is, you don't see, look at the record, there are undoubtedly some forms of oscillations going on, like La Nina and El Nino, but there's nothing that can really account for a long-term increase or the long-term increase that we've seen. So yeah, undeniability, I think, is a psychological thing as much as it is a data thing. But anyway.
Okay, and of course everything we talk about, you know, is generally linked, but this next story more so, that talks about the warm ocean currents that are causing the majority of ice loss from Antarctica.
Yeah, now this is a really interesting paper. Came out last week in Nature, and if you can load the scripts page, that's the one, and go down to the big map of Antarctica, because it shows a number of interesting things. Now, Antarctica, as we know, is a big cold continent. It sits at the South Pole, and it's very high in the middle. There is very few parts of the landmass of Antarctica where summer temperatures actually get above freezing. So, with the exception of the Antarctic Peninsula and some parts, the Antarctic Peninsula is the bit that sticks up towards South America, and some limited parts of the West Antarctic, you don't get very much in the way of surface melting. Now that's in direct contrast with Greenland, where very large parts, if not most, of the surface of the Greenland ice cap in the middle of summer actually gets above freezing, and so you get surface water runoff, and you get these wonderful pictures of water plunging down chasms to the bottom of the ice on Greenland.
Yeah.
It's clear and obvious that there's a large amount of melt going on. With Antarctica, as I say, again, with the exception of the Antarctic Peninsula, which is the fastest warming place on the planet, we're measuring substantial amounts of ice loss when we look at the data coming from, say, the gravity satellites, the GRACE mission. They show a prolonged and continuing and increasing loss of ice mass from the Antarctic continent. And there's long been a suspicion that what's been going on is that the changes in the climate and the wind patterns around Antarctica have been changing ocean circulation to bringing warmer water up underneath the fringing ice sheets and melting some of that ice off. Now, what this new paper has done is they've looked at the NASA IceSat, which is the Ice Cloud and Land Elevation Satellite data, and to estimate the changing thickness of almost all the floating ice shelves around Antarctica. And the map that Glenn's got on screen at the moment shows where that ice loss is actually happening. So you're looking at as much as 7 meters of ice shelf thickness change. That's the darkest red, or the brightest red, regions in West Antarctica around the Pine Island, Thwaites Glacier part. And what's happening is that ice loss is propagating back inland. That you can see measurements. If we go on to, I think it's the British Antarctic Survey. No, they haven't got that map there, I don't think. That kind of propagates itself back inland. And yeah, okay, can you go on to the climate progress page, which is the third link in the show notes there, Glenn?
Yeah.
And the top graph, that's the one. The top graph shows how the ice inland has been thinning at the same time as the ice sheets have been thinning. So what's been happening is that these ice sheets are big. They're hundreds of meters, if not thousands of meters of thick ice clinging onto the coast. So the glaciers come off the center of Antarctica, come down to the sea, and then they form these floating ice shelves. And what that great mass of ice floating does is kind of acts as a brake on the ice leaving the continent.
Right.
So as the ice has been melting at the bottom of these ice sheets, so the glaciers have been able to speed up, and so the amount of the thinning, if you like, spreads back inland. And this helps to explain how we're seeing, the rates of mass loss in Antarctica when we're not seeing the sorts of surface melt that we see in the Northern Hemisphere. So it's a really interesting paper. I'm not really doing the complexity of it justice in this. So I'd strongly recommend listeners and viewers to go and have a look at the press material from the Scripps Institution of Oceanography and the British Antarctic Survey, because there's some good and interesting material in there. And as so often he does, Joe Rom at the Climate Progress blog provides some very good coverage of it. So
unrelated to that, and I know we're not covering it in the show notes today, but anything we can say about the findings about the Himalaya glaciers and the fact that they were gaining ice, not losing ice?
Well, I think the key thing with respect to that, and I will find a link and stick it in the show notes if you like, Glenn.
Yeah.
But it was a part of the Himalaya are gaining ice mass, not the whole chain, which is very large. And behind the Himalaya, there are the very high parts of Tibet, which have their own ice sheets on them. So what you're seeing is not a straightforward picture of everything losing the same amount of ice everywhere you go. You're looking at I think it's the western ice sheets, the westernmost glaciers of the Himalaya and Karakoram ranges may be gaining a certain amount of ice, whilst others are losing ice, and that's because of local climate differences. Now, it could be that the glaciers in the west are getting more precipitation, so more snow is falling on them at the beginning of or during the cold season, so that the ice is building up, and the melt at the bottom of the glacier is not balancing that out, so the glacier mass is actually growing. A similar sort of thing is happening in New Zealand and to a certain extent in Norway as well, where the glaciers on the west coast of New Zealand, on the west of the Southern Alps of the South Island of New Zealand, are expected to actually gain in mass, ice mass, as the climate warms, because more precipitation, it's very wet up there at the top.
Yeah.
It's going to continue falling as snow for some time. So as long as you're getting a lot of snow coming in, more than is melting off at the bottom, then you get more ice. Across to the other side of the Southern Alps, they don't get so much precipitation. There the temperature will drive mass loss. And so you get this sort of subtle differences depending on the position of the ice, the glaciers and the snowfields that feed them, to the local or regional climate. So with the Himalaya, you've got, it's a vast mountain chain. It's thousands of kilometers long and very, very high, and different climates in different parts.
Okay. All right, good. Thanks for that brief explanation on that one. Let's move on to the next story about some US and Australian scientists have found that the cycle of evaporation and rainfall over the past 50 years has intensified at twice the rate predicted by climate change models. And what that means is dry parts of the planet are to get drier and wet parts wetter.
Yeah, I mean, that's not unexpected. We do know that from all sorts of measurements that the amount of water vapor in the atmosphere has increased as the planet has warmed, and that's one of the key things that's driving the changes in extremes, particularly water vapor in the atmosphere. Meteorologists often call it the fuel that drives storms, because as water condenses, it gives heat off, and so on. So you end up with more fuel in the atmosphere to drive extreme weather events. Now, so in one respect, more water vapor available means more rainfall.
Yeah.
But more warming also means more evaporation, which means more drying. So if you've got areas that are prone to drying, you'll get more drought. If you get areas that are prone to more rainfall, they get more rainfall, get more flooding, you get, and so on. Now, what these scientists have done is, it's actually very difficult to get a very accurate picture of how the amount of water in the atmosphere has changed over a long period of time, because the records are primarily land-based. They depend a lot on the local climate, just because the pattern of weather changes so much from place to place. And so what they've done is they've looked at figures for ocean salinity. So if you can think of salt water in an area where more rainfall falls, the water becomes less salty. And in areas where more water is evaporating, it becomes more salty. And so they've been able to look at the data for oceanic salinity that's been gathered over the last 50 odd years, and they find clear evidence of an increase in the amount of water vapor in the atmosphere. Now, what they have gone on to say, and this is a little bit more controversial and not necessarily totally accepted within the community, is that this means, their evidence suggests that the modeling that we do on the way that climate operates has underestimated the amount of this water vapor feedback that's going on. And they go on to suggest that the rate that they've measured is double the response projected by the current generation of climate models. And they suggest that if the world warms by 2 or 3 degrees, then there will be a substantial, and I'm quoting from the abstract of the paper, a substantial, or 16 to 24%, intensification of the global water cycle. Now that's significantly more than people had expected based on the way the models are currently working. And the intensification of the water cycle means more drought, because you get warmth evaporating water away from areas prone to dryness, and a great deal more in terms of flooding and heavy rainfall events, which is, it's often regarded as sort of strange that an intensification of the water cycle means more drought, and also more flooding. But two things, but two sides of the one coin.
Yeah, and also interesting the effect that this will have on geopolitics, right? Because the rich countries generally have a lot of water. I mean, that's just the populations were attracted to areas where there was lots of fresh water, because it's what we humans need, right? So the rich kind of get richer in that respect, and the poor countries who are drought prone, things will only just get worse for them.
Well, yeah, I mean, water is certainly an important economic resource, and you've only got to look at the fights that, even in New Zealand, which is a relatively water-rich country, the fights that people have over access to water are a significant driver of local politics. But I think it goes a little bit beyond that, because it's not as straightforward as just more water. If the water is arriving in extreme rainfall, now over nearly 2 years we've been doing the show now, Glenn, we've talked about a lot of floods in Australia. We talked about record rainfall events around the world, and some of the dramatic increases in extreme rainfall events that we've seen, records being beaten by a factor of 100%, in other words, double the previous record. Those sorts of things are immensely damaging. I don't know if you've ever been anywhere near a body of water that's large and moving very fast. There is an awesome amount of power in those things, and the damage they can do is huge. I mean, some of the pictures you'll recall the flooding in Queensland last year, the Toowoomba flood, for instance. Some of the pictures of cars being floated away, houses being destroyed, and so on, quite remarkable. And an intensification of the water cycle means we are likely to see a lot more of that. It will be in the areas where currently you get a lot of rainfall. If you're a farmer and you've had a flood on your land, then you should be preparing for more.
Yeah, and interesting to say that, because on a local level, the Hamilton City Council, Waikato District Council there, were warning residents in all kinds of areas about the potential for flood in the area, a 1 in 400 event. I think they were saying 1 in 400 year event, and that was being kind of mocked by the residents, because some of them live on sort of elevated sites, but a lot of people don't seem to be taking that sort of stuff seriously, even though New Zealand has had some pretty extreme flooding events over the past couple of years in places that haven't experienced anything like it before.
Well, that's right, or perhaps not in living memory or since European settlement. Yeah, it's a difficult thing, because extreme events are by their very nature relatively rare. But if they are becoming either more frequent or more extreme, and it can be both or either, then this is where adaptation to climate change is so important. This is where communities have to find a way to plan to deal with increases in the extremes that they're going to face. So that may mean that you need to put in bigger storm drains when you're building a new housing subdivision. It may mean that you've got to take into account, rising sea levels in an estuary when you're planning to rebuild a city like Christchurch. All of those things are a key part. Often we talk about when we talk about solutions in this podcast, that we focus on the technologies that can help us to reduce our carbon emissions, but just as important as that are finding ways and means of enabling communities and societies to adapt to the changes that are actually now inevitable.
Talking about adapting on a natural level, we've talked about coral and the effect that climate change and warming oceans will be having on coral. Well, there's a new study that suggests that the Pacific Islands may in fact become a refuge for coral populations as the climate warms.
Yeah, this is a fascinating paper that came out at the end of last week, and I popped this in first of all because you don't often get a lot of good news about coral. We've heard from scientists over the years that suggesting that oceanic warming is going to be a pretty horrible future for the corals of our tropical oceans. But what these scientists have done, and this is from the Woods Hole Oceanographic Institution in the US, they've noticed that there's a colder current in the equatorial ocean. It's called the equatorial undercurrent, and it flows at about 100 to 200 meters below the surface. So you get warm waters moving from east to west, which is the affected by the winds. The warm water blows across the Pacific, and then to balance that underneath, there's a swift countercurrent, is how they describe it, and it's cooler and it's rich in nutrients. Now, when that undercurrent hits an island, it gets forced up to the surface, and so you get a what they call a local upwelling process, which is bringing cooler water, nutrient-rich waters up to the western side of that island or group of islands or that rock or reef or whatever. And in that area, you can get you'll get coral growth, get fish growth. It's a very good place for sea life because it's very nutrient-rich. And they've looked at satellite pictures, and they've looked at pictures of global of the chlorophyll in the surface waters. And if you just scroll down that page,
is it that one we're looking at?
That's the one. That's the one. That shows the chlorophyll in the surface waters, and you can see that they're quite strong around the Galapagos Islands, which is sort of to the west of the top of South America, out there immediately below Central America, I guess, Mexico, Central America. And that's one of the reasons why the Galapagos are a fantastic kind of wildlife place. But they also then, they looked at the maps, they found that there were other areas in the Western Pacific, particularly around Kiribati. Now, they call them the Gilbert Islands, which I think is possibly not a good name to use for Kiribati. But perhaps we ought to talk to them a little about their geography. But anyway, so Kiribati and Tuvalu are islands where you can see this again. There's a map. If you go to the one below, Glenn, that shows how the chlorophyll increases as the undercurrent pushes up to the west of the islands. That's that big green patch that you can see there. And so what these scientists are saying, that the models are predicting that the ocean temperatures in the Pacific will rise by, Central Pacific will rise by nearly 3 degrees Celsius. These waters are a degree or two cooler than that and will be bubbling up to the surface and provide a sort of refuge for corals that can't survive. Areas may provide a little kind of lifeline for species. Places where things that simply can't tolerate the warmth will be able to cling on to life, as it were. And they could become islands where recolonization could take place if we ever manage to get on top of this climate thing and turn it round and start the planet cooling down a bit.
So effectively we'd have to transplant coral from other places, from the Great Barrier Reef, places like that.
Oh, I don't. Well, possibly. I haven't seen any suggestions of people doing that yet. But I guess if you get worried that large parts of your Great Barrier Reef are going to go, it's something you might want to look at.
Well, otherwise we're only going to have coral in a big fish tank in James Cameron's house or something. Otherwise,
yeah, that's why he's moving to New Zealand.
Yeah.
No, but I just thought it was fascinating because we read a lot about how sea level rise is bad news for the tropical Pacific, but there are other, the climate system and the oceans are immensely complex things, and what this study has done is pointed up one, if you like, counterintuitive effect of an increase in global ocean temperatures that could actually provide a bit of a lifeline. So I thought it was a fascinating thing to look at, but also an interesting little bit of positive news, perhaps.
Good. Okay. Well, the next one's a bit of a no-brainer, and I think experts have been telling us about this for decades now, but the world needs to stabilise population and cut consumption. This time the Royal Society has come out and said this.
Yeah. Now, I'm not going to go into this in any great detail. I have to say, not everybody, or rather, depending on your viewpoint, you'll find things to like and things to dislike about the Royal Society's efforts to dig into this whole kind of multiple crunch that we're facing.
Yeah.
But I wanted to put it in because it is a valuable contribution to discussions, because climate change, as we've often said on this show, is only one symptom of it's one consequence, if you like, of the fact that there are 7 billion people on the planet, 9 billion by 2050 or whatever, who are all desperately trying to enjoy life, have the best life that they can, improve the lot for themselves and their children and so on, which is how basically our civilization has behaved over the last couple of thousand years. We've always wanted to progress and do better, but there are so many of us now, and the things that we're capable of doing in terms of building cars, planes, traveling, everything else, having severe consequences for the planet. And so the Royal Society has looked at the evidence, and what they've done is they've come up with some key recommendations, and I wanted to just quickly draw everybody's attention to these, because they're certainly worth thinking about at the very least. And what I liked about it most was the fact that their first key recommendation was that the international community must bring the 1.3 billion people living on less than $1.25 per day out of absolute poverty and reduce the inequality that exists in the world today. Now, that's really important because apart from anything else, most of the impacts of climate change are going to be most severe in the areas where those poorest people are living. You take Bangladesh as an example. It's hardly the richest country in the world, and yet it's on land which is very likely to be flooded out by the end of the century.
Indeed, yeah.
So often people think, rich countries looking after themselves may be the realpolitik, but we have a duty as a civilization, if you like, to try and look after the poorest, just as we do in our day-to-day life or day-to-day civilian life, if you like, the civics of living in New Zealand. We provide protection for the poorest and least able in our society to try and give them some form of decent life, and we need to do that on a global basis as well. The other thing that's really interesting is what they're talking. They talk about developed and emerging economies must stabilize and then reduce their material consumption levels. And they talk about doing this through dramatic improvements in resource use efficiency, reducing waste, investment in sustainable resources, technologies and infrastructures, and then, most importantly in my view, systematically decoupling economic activity from environmental impact. And that is absolutely critical, because environmental impact from where we're coming from, Glenn, is climate change.
Yes.
But it's a lot more than that as well. It's the use of nitrogen, which is becoming a really serious pollution issue around the globe. We've added a huge amount of nitrogen to the nitrogen cycle that previously was not available. We have to somehow find a way of creating economic activity that doesn't take us out beyond the bounds of sustainability, and that's not going to be trivial, because our whole economy is built around growth, doing more, using more, and planning and seeing. There seems to be very little in the way of discussion of alternatives to permanent growth. Now, we know that when I say discussion of, I mean discussion of by the politicians who are running our societies. We don't find there's if you look at New Zealand politics, and I'm sure this is true for British and US policy and Australian politics too, you'd be hard pressed to find any non-green politician who thought that growth was anything other than the most desirable thing.
Yeah.
So
it's this constant requirement for year-on-year GDP growth, and the success of an economy and a country and a population is measured on that. And if you're not doing that, then you're in something called a recession, and that's really bad.
Yeah, that's right. That's right. And we do need to go beyond measures that are only measuring economic growth and look at the quality of life and the sustainability of that quality of life. So the report, the Royal Society's report, is a long and complex document. It's not specifically about climate change, but climate change is certainly one of the factors that they're looking at. And I just thought I'd throw it into the show as something that people might want to dig into, have a read of, argue about, whatever. But certainly a very worthwhile effort.
Good. All right. Well, very shortly we will get John Cook on to dish out some skeptical goodness. In fact, he's going to be looking at the concept of lag and how some people think that it's temperatures rising first that causes CO2 to rise, and so we're going to be digging through that. But yes, you were going to say?
No, I was going to say that it's again a new paper that came out that's not been without a certain amount of controversy, at least amongst the usual suspects, but really fascinating picture of what happens at the end of the last ice age.
Good. So John Cook with that up next, and also we'll have some solutions at the end of the show as well. But first up, I do want to thank some of our media partners for helping spread the word about the climate show and get it out to as many people as possible. Sciblogs.co.nz, first of all, great science community of bloggers all around New Zealand who communicate sort of directly rather than through the institutions, universities, communicating directly with people about science. And also thanks very much to idealog.co.nz, the sustain section there of the Idealog website, and scoop.co.nz and livenews.co.nz as well. Live news feeds the climate show back through Scoop, which is really nice of them as well. And also thanks very much to our technology partner Intel, who provide the rig where this whole show is recorded. They provide the motherboard and processor chip to make everything run fast and smooth. So thanks very much to all of them. Right, let's get John Cook on.
And it's my great pleasure to welcome John Cook back to the show. After a few weeks of peace and quiet, he's agreed to come back and give us the benefit of his wisdom. Welcome back, John.
Hey Glenn, hey Gareth.
Hi John. Yes, nice to have you back. It's something I'm interested in talking about before we talk about lag. I saw you tweeting about this show in Australia on the ABC network there. What was it called?
I think it was called "I Can Change Your Mind About Climate."
That's right, yeah. Which was an intriguing title. First up, what was it about? How did it unfold?
Well, the idea was that Anna Rose, who's a climate, activist for the Australian Youth Climate Coalition, she coupled up with Nick Minchin, who's a retired Liberal senator and a very well-known climate skeptic in Australia, and they basically took each other around to see various spokespeople or climate scientists or people who are very strongly opinionated about climate change, and try to convince the other person of their point of view.
Okay.
So Anna was trying to convince Nick that humans are disrupting climate change, and Nick was trying to convince Anna that it wasn't a problem.
Right, great concept for a show. Was it all entertainment value, or did it have some actual guts to it, and some actual science and something that people could get into?
Yeah, there was a lot of controversy even before the show had started while it was getting made, and I think a lot of people told Anna that there was a danger that by giving oxygen to a lot of these marginal climate skeptics and by letting, giving them a public voice, then what you were doing was basically raising up all these non-experts, bloggers and political lobbyists, up at an equal level with climate scientists and experts. And so as far as the public were concerned, they could come away with this impression of an ongoing debate when it was actually non-experts arguing against what the experts were saying.
So back to that whole thing of journalists wanting to find balance in the story.
Yeah, it's the false equivalence, isn't it, John?
Well, that was the one danger. But what the producers, I think, were trying to achieve was they could see that climate was such a polarizing issue that their goal was to try to find a common ground between the two sides. And so I think what they hoped would come from the documentary was that Anna and Nick would find points that they would agree on, like that we do need to increase renewable energy for reasons other than climate. And so, yeah, that was the kind of noble goal that they were hoping to get from it.
Yeah.
But I think because some of the people that Nick mentioned chose as his experts were extreme bloggers from Australia and political lobbyists from America, these were people who weren't interested in finding any common ground, but they were about as extreme as you could get in their views.
Cool. Is there anywhere online we can see the whole show?
I think the ABC website might have it online.
Could be geo-blocked, of course.
Well, yeah, it could be. Like ABC have their iView website where they let you see your old shows online. So, yeah, you would have to check the ABC site.
Okay.
Sorry. If I find a link, I'll give it to you guys to put in the show.
But there is a YouTube clip of something that didn't make it into the show that you think's worthwhile seeing. Yeah,
well, see, both Nick and Anna had like 6 different people that they showed introduced the other person to, and of the 6 people that Anna chose, 3 of them didn't even make it into the final documentary, because I guess they had hundreds of hours of footage and they had to boil it down to 1 hour. And so one of those was Ove Goldberg at the University of Queensland, where I work. So he actually took them up to Heron Island and spent a whole weekend with them, showing them all the latest science they're doing on impacts of climate change on coral reefs. So that was a real shame. And all they got from that into the final documentary was just some footage of Nick and Anna walking and talking on a beach and a nice picturesque location. Okay. But no sign of Ove, unfortunately.
Well, so it is up there on YouTube, but we thought we would include it in here on the show.
Let me give a quick introduction to this clip. Now, the other expert that Anna had was Naomi Oreskes, who wrote the book Merchants of Doubt. And what she did was explain to people, or explain to Nick, why a lot of people reject climate science. And I think that was really the key lesson that could have come from this documentary, was explaining what are the driving forces behind people rejecting the scientific consensus on climate change. So it's a big shame that this footage didn't make it onto the into the documentary. But fortunately, the producers did grant me permission to post it up on YouTube so that people can still see it.
Okay, cool. We'll pop it in here now and check this out.
So how are you feeling about meeting Naomi today? What do you expect?
Well, I always look forward to meeting new people, and I've only recently heard about her, and all I have read of hers was that speech she gave in Sydney when she was raising real doubts about the motives of some of those on the sceptical side of the argument.
And the accumulated scientific evidence is overwhelming that the globe is warming, and that the major driver, there are other causes as well, but the major driver is greenhouse gases, of which the most significant is carbon dioxide from burning fossil fuels. So that is, in the scientific community, really in a sense indisputable. And to reject that would be equivalent to rejecting the idea that earthquakes are caused by plate tectonics, or that vaccinations prevent disease. And I'm sure you don't reject those things. So that makes me wonder if the reason you want to reject the science is that it has consequences. It has consequences for us about how we live our lives, how we run our economy, what our taxation policies are, and that's your territory, right? Sure. And so I think, and you can tell me if I'm wrong, I think that what you don't like are the implications, the political and social and economic implications. But what you've done, along with a lot of other people, is instead of having, let's talk about those implications, let's shift the debate, let's argue about the science, let's keep the debate about the science going, because as long as we argue about the science, we don't get to this other question about what it means for us socially, economically, and politically.
Yeah, obviously the two are linked. You cannot separate them. And so for people like me, having been in public life and in government,
Right.
if very significant economic change is being proposed as a mechanism for dealing with a problem, you've got to be
Damn
you've
sure.
got to be damn sure we've got
And
a real
I
problem
agree with
here.
you about that. I agree completely. We're talking about a complete transformation of the energy system,
right.
which is the basis of our economic activity. So I think you're 100% correct to say we want to make sure that we move forward with confidence, that we're basing our decisions on good information.
Yep.
But here's the thing, you're not doing that. Because by rejecting the science, you're actually making a decision on bad information. You're accepting information for people who have their own reasons, motivations for denying the science, motivations that do not come out of problems in the scientific evidence. People I've studied, one of the things that they feared was a kind of massive government intrusion in our private lives.
Yeah.
And I agree with them with that. I don't want the government telling me what to do. But the longer we wait, the worse this problem gets. And the longer we wait, the more likely it is that we're going to have to do things that you don't like. If we start doing it now, we can have an orderly transition. If we wait until we have a crisis, then there's going to be panic, and then I think it's going to be much worse. And then I think you're going to see a lot of government interventions that you don't want to see at all.
Golly, confrontational, but also cordial at the same time there.
Yeah, she's great, Naomi. She's just a fantastic communicator, and she says it clearly, and she just sums up the whole issue and really well.
Yeah.
Yeah, there are two things that I got from that clip. The first is that never argue with Naomi Oreskes. And the second thing is that she's obviously read your Skeptics handbook, because she does that beautiful thing of identifying with the person that you're talking to.
Well, I'd say that she's been doing that for many years.
And a one-to-one conversation, she's finding common ground in order to make her position persuasive.
Yeah.
The funny thing is, when she toured around Australia a year or so ago, and she gave talks about climate change and merchants of doubt to audiences in every capital city in Australia, and out of all those talks, only one person got up and asked a contrarian skeptic question. So maybe the audiences also realised, don't argue with Naomi Oreskes.
All right. Well, that's very cool, and you can see the blog post about that up at skepticalscience.com. But John Cook is with us, and we're going to debunk a skeptical argument now. This one, clarifying the CO2 temperature lag. Is it in fact that the temperature rises and then CO2 rises because the temperature's risen?
Yeah, okay. Well, you've managed to make it confusing already.
Yeah.
So.
It's my job here.
let me take a step back, and I want to ask you a question, Glenn, a scientific question, just to test your level of knowledge.
Okay, here we go.
All right. So answer me this question. Do chickens come from eggs, or do eggs come from chickens?
Isn't that the eternal question? Hang on. What did you just say? You didn't just say what came first. You just said, do chickens come from eggs?
Do chickens come from eggs, or do eggs come from chickens?
Well, it is the same thing as what comes first, chicken or the egg. Eggs come from chickens. Chickens come from eggs.
Right. Okay. So both is what you're.
Yeah.
Man. Okay. So now just imagine if you met a chicken skeptic who didn't believe.
They don't exist.
Well, they might be skeptical that chickens lay eggs, for instance. All right. And then they showed you footage of an egg hatching and a chicken coming from it, and they said, "Here you go. Here is proof that chickens come from eggs. So therefore, eggs cannot come from chickens."
It's not true. Yeah. So what are you getting at?
Well, what I'm getting at is that's a logical fallacy, and what I'm going to try and do for our debunks for each climate show from now on is not just explain the science, but also explain how these climate myths mislead people.
Okay.
Because you really need to understand the techniques involved and get kind of the big picture, and not just kind of get lost in all the nitty gritty of the science.
Sure.
And so with this CO2 lag issue, it's basically it's all based on a logical fallacy, which is that either CO2 lags temperature or temperature lags CO2. Or one can only cause the other, and you can't have both. And so So the situation is that around 18,000 years ago, our planet was in an ice age, and then it started to warm because of orbital changes. And then about 500 to 1,000 years later, CO2 levels went up. So I hope this comes out in that graph you're showing. But that red line there is temperature in Antarctica from Antarctic ice cores. And you see that around 18,000 years ago, it starts warming. Now, all those little yellow dots are CO2 levels.
Okay.
Now, if you look at it really closely, you can see that the CO2 started to go up after it started warming.
Yes.
So warming came first,
yes.
then CO2 levels went up.
Uh-huh.
So basically, warming caused the CO2 levels to go up. And what skeptics will say is, aha!
Yeah. In true Alan Partridge style, aha!
Warming causes CO2 rise,
yeah.
Not the other way around. CO2 doesn't cause warming. And that's your logical fallacy. It's like saying that if chickens hatch from eggs, then therefore eggs can't come from chickens.
Yeah.
So in actuality, we have both. CO2 causes warming, and warming causes CO2 to go up. And when you put those two facts together, what you have is a reinforcing feedback. It warms, CO2 goes up, that causes more warming, and that causes more CO2 to go up. And that's basically the main mechanism that drives our planet out of an ice age. And so what's happened is over the last few weeks, a new paper has come out that just looks at this issue in more detail. And basically, it confirms what we already understood, the explanation I just gave.
Yeah.
But it also fleshes out a lot more details. And that graph I just showed you showed that red line, which was Antarctic ice cores. But what the new research does is it looked at measurements of temperature going back 20,000 years from all over the world, from Antarctica, from Greenland in the north, from ocean sediments all over the planet, and from various lake sediments. And yeah, this is a bit of a brain buster, this graph, to try and interpret it. But basically, those red yellow lines are the southern hemisphere and Antarctica.
Yeah.
And what we see is that Antarctica warms first, then CO2 goes up, and then the northern hemisphere, which is the blue and the purple lines, warms afterwards. And when you
But first of all, what's the source of that CO2 though? When it's warming naturally like that, where's the CO2 coming from?
It comes from the southern oceans.
Okay.
Because as the Antarctica and the southern hemisphere warms, the oceans warm, and warmer water releases CO2.
Right.
It's not able to heat up, not able to absorb as much CO2.
Yep.
So that's why, when the southern hemisphere warmed, all this CO2 got released into the atmosphere, and then that spreads the warming across the globe and also amplifies the warming.
Good. Okay, happy with that.
And so there was another graph they showed which compared the lag and the lead between the southern hemisphere and the northern hemisphere. And I don't suppose you'd be able to bring up that graph.
Yep. Coming right up. There it is.
And so what this shows is that all those red ones to the left of the graph, that's the southern hemisphere.
Yep.
And in the southern, the temperature leads CO2. So it warmed first, then the CO2 went up. But in the northern hemisphere, it's the other way around. The CO2 went up and then it warmed. And so basically this new research confirms what our understanding of what was happening with the southern warming first, and then it's spreading to the rest of the planet. And it also confirms that both that CO2 causes warming and that we have a reinforcing feedback situation with the carbon cycle. So when people say CO2 lags temperature, therefore there's nothing to worry about, what it actually tells us is that the carbon cycle is a positive feedback or a reinforcing feedback, and it takes a while. It takes hundreds of years to kick in, but that is something that we're putting into motion now by causing warming.
So, which is the present, as you say, the present and future worry about this constant feedback loop and a tipping point as well.
Yeah, I guess it's a legacy that we're creating now that future generations are going to have to inherit from us.
Okay, well that's pretty much clear. You happy with that, Gareth?
Yeah, absolutely. I was very impressed by the paper because it does address this key logical fallacy that John's been talking about, but also because it throws a very interesting light on the discussion about how the Earth warmed out of the last ice age, because it ties together the two hemispheres. And there's been a lot of discussion, a lot of theorizing about northern hemisphere triggers southern hemisphere warming. How are they all linked? And what this paper does is hypothesizes that you get the Earth's orbital cycles, the Milankovitch cycles, triggering the warming in the northern hemisphere, because more sunshine arriving melts ice sheets, gets the that puts fresh water into the oceans. That affects ocean circulations, which allows heat to accumulate in the southern hemisphere, which then gets the CO2 moving, and so you then get a feedback, the carbon cycle feedback, that warms the whole planet and kicks us out of an ice age. So yeah, fascinating to see it, to have a look at this paper. Having said that, I do think it's probably not going to be the last word on this. I'm sure there's going to be a lot more work that's done as we get more data and as more people look at it and apply their minds to it. So I wouldn't say this is any kind of final answer, but it is a very good exposition of why this lead lags thing is actually complex and fascinating and nothing at all to do with what we're doing now.
Indeed.
No, and the funny thing is the CO2 lag myth is actually one of the top 10 myths in our database. So out of all the different climate myths that get used the most often, this is actually number 10. And so
yeah, that's right.
So when this paper came out, there was this knee-jerk reaction from a lot of the different blogs that reject the scientific consensus on climate change. So criticizing various elements of the paper, and the reactions were so quick and so knee-jerk that the criticisms were quite silly, most of them. They were very shallow arguments. But it was interesting to see that just that instant knee-jerk reaction from a research which basically confirmed what we already knew, and then just fleshed out some more of the details about the northern and the southern bipolar seesaw effect. So yeah, I thought that was an interesting insight into how people react when one of their sacred cows get debunked.
Absolutely. And Gareth, of course, there is a short URL link.
Oh yes, of course. Hang on. Let me just find the right. Yes, there are several. In fact, what we've got, of course, for the Naomi Oreskes clip, John has quickly cobbled together an sks.to URL, and so it's http://sks.to/Minchin. That's MINCHIN. And then you'll be able to see Mr. Minchin in all his wonderful glory. And then the others are http://sks.to/lag, and that will take you to the page discussing the Shakun paper. And also then, I'm not going to do all these HTTPs, it gets a bit boring. But anyway, /Shakun, SHAKUN, will take you on to the SKS page dealing with that paper.
Yeah, I'm disappointed. You missed out the www. That's really
no, there are no www.
Oh, there are. Okay.
We covered this in a previous show.
That's right. Keep up. Come on. Excellent. Well, that's been a really good session with John Cook there, and of course you can head along to skepticalscience.com for all that, and also in the show notes if you missed any of that, all the links will be there as well. And as you say, John, we're into a groove really with this segment within the show. Any idea what you'll be covering next time?
Well, I guess what I would like to do is just go over all the climate myths that rose to prominence between shows, and we can just go through each of them. And what I would like to do is look at those rhetorical arguments and logical fallacies and different techniques that they use. So we'll explain the science, but also explain the techniques that are behind them as well.
Okay, well, and I think we'll stop calling it debunking the skeptic, and we'll call it Cook's rapid response from now on.
Well, it's not that rapid if it's like 4 or 5 weeks between.
Yeah, well, that'll keep us on our toes, won't it?
Well, it will need an animated graphic. Cook inside like an ambulance or something with the lights and a siren going, heading along. And skeptical science on the side of the ambulance or something. If anyone wants to mock up a graphic that we can use, a rapid response.
Oh dear. Anyway, John, thank you very much. That was great. Most interesting little session, and thank you for introducing us to that Naomi Oreskes clip.
All right, thanks, guys.
Cheers. See ya.
Cheers. Bye-bye.
And now we're into the final segment of the show, the home run, if you will. I think that's how you'd put it, a home run, hitting a home run. I don't know. Anyway, we're into the solutions segment. That's all I want to say. Looking forward to a lower carbon future, things that'll help us on that journey to perhaps a greener future as well. And just while on that, relating to solutions, I had on my radio show on Kiwi FM, I had Chris Payne, the director of Revenge of the Electric Car, who's been on this show on a previous episode. He was in the country in New Zealand for the first time since I think 1981. I think the last time he was there, so things have changed a little bit around the space. But he was, because finally the Revenge of the Electric Car has come to New Zealand. It's at the Documentary Edge Film Festival, which is still on now in Auckland if you're in New Zealand, or Wellington as well. And then hopefully it'll be released on DVD or streaming or something along those lines so everyone can see it. I really recommend that as a good watch. And certainly electric cars are part of the solution. Right, now let's look at the first story, tinted windows that generate electricity, Gareth.
Yes, absolutely. This is a story I got from Technology Review, the MIT website and magazine. A German company has basically found a way of using the same sort of manufacturing process that makes OLED displays. Now, those are the next generation of kind of cell phone, tablet, television display technology, which give you very bright, saturated colors. And this is they can print it onto a flexible panel, which can then become part of a window. So you can be sandwiched in glass or whatever, and can be put up onto into buildings in windows, and they will generate electricity. The company's called Heliotech, based in Dresden, and they've just raised I think it's 28 million euros to start making the panels on a sort of proof of concept production line, and then they're hoping to get another 60 million euros, which they'll use to build a factory with a 75 megawatt production capacity. They think they can probably get the price down in large scale production to about 40 or 50 cents per watt of power generated, which is competitive with where conventional solar panels are likely to be at that time. So yeah, it's an interesting thing. It just shows that you can use these clever technologies in all sorts of ways to harness the solar power. And obviously windows transmit light. They're not often optimally sited to get light, but if you think about tower blocks, for instance, which have huge expanses of glass pointing at the sky, a building could generate a very acceptable chunk of its power requirements, and so by fitting this sort of glass.
And so a black van with tinted windows doesn't have to be dodgy. They just could be generating a fair amount of electricity for that.
Yeah, they may be powering those big subwoofers that all those big black vans have.
Yeah, well, something and perhaps a reason because there's laws in New Zealand around how tinted your car windows can be. But I mean, if this was a way of powering a vehicle, then they would have to look at changing those laws.
Oh well, possibly yes. I don't think the cells are actually efficient enough to be able to generate enough electricity from the glass roof of your car to let you drive along. But yeah, I think it's much more architectural interest.
Yes. Yeah. Okay, on to the next story. NASA is funding a satellite, gosh, this is futuristic, that would beam solar power back down to Earth.
Yes. The idea is not new, but it's basically if you put your solar energy collector up in space, you get kind of more hit from the sun than you do if you put your collector at the bottom of the atmosphere. So you get a nice sort of energy advantage by being up in the relative clarity of space. But then, of course, you've got to get the power down to Earth. And what they are talking about is sending it down as a constant stream of microwaves. So you'd basically beam the power down to a spot on Earth. They're also talking about using fairly clever designs for the collector that they look a bit like flowers, and in fact they call it biomimetic design. So meaning mimicry of biological structures. So lots of thin film mirrors curved to direct the sunlight to the solar cells at the bottom of the flower or petal-like structure. There it's converted to microwaves and it's sent down a tight beam to Earth. They reckon it can be done for a not stupid cost because it would be very light. The big worry for me particularly, I think sort of immediately sprang to mind, was that if you had one of these things up in space orbiting around the planet, beaming power down to Earth.
If it went to the wrong place.
Exactly. If it kind of wandered off spot, you could...
Yes.
Yeah. So
Well, this is could be a weapon, could it not? Could be like a laser type weapon.
absolutely. Well, it would be a cooking weapon. You
Yeah.
know. It would come down and it would basically cook however wide the beam happens to be at the point where it hits the Earth.
Like you could cook a missile launching site, for example.
Well, that's right. Yes, absolutely.
For those listening to the audio, it kind of looks like a chandelier in space or a jellyfish.
Yes, or a thimble or something.
Thimble, yeah.
Yeah.
Very
But
cool.
yeah, it is a cool idea because the energy advantages of getting your solar power from space rather than from, as I say, at the bottom of the atmosphere, where an awful lot of it gets filtered out by the gases and dust and clouds and everything else. There's certainly an advantage in that. But obviously you could conceive of systems where the beam of microwaves would be automatically switched off if the satellite position changed or whatever. But I think if people are worried about having wind turbines at the bottom of the garden, I think I would be considerably more worried about having a satellite microwave collection dish anywhere near my house.
True. All right, well, moving on to the next story. First look at an airborne wind turbine prototype. This is interesting.
Yeah, absolutely. It's one of the things about extracting energy from the wind is that the wind close to the ground tends to be less reliable and less strong than winds when you get higher above the surface. The problem, of course, how do you get a turbine up to the sort of levels where the wind is more reliable? Now, one thing you can do, obviously, is to build a conventional wind turbine and stick it on the ridge of a range of mountains.
Yeah.
And that's very effective, and that's being planned for my valley in the next few years.
That's exciting.
Yeah, absolutely. I'm looking forward to seeing how it all
How does this thing not? Because it's a turbine in the middle of a helium balloon, really, isn't it?
So
why doesn't it blow away?
Well, no, because it's tethered, of course. You know, it's tied to a place on the ground, which is how it gets its power back down to the base. Other people have done it with exploiting higher level winds by using kites that fly in figure-of-8 patterns and so on. So it's not a novel idea to get something up there. But what's interesting about this is the design, which is like a donut, which tends to focus the wind in towards the turbine at the middle.
Yeah.
And so it makes it quite efficient. And the idea that it's easily deployable, that, you can see it there on the YouTube video, that it's basically sitting on the back of a truck. You just drive it along, sort of unwind the winch, it goes up and finds the wind and generates. So the company doing this reckon that it can be done at competitive prices, possibly with a smaller footprint than conventional wind turbines. I
haven't read fully into the article, but you'd imagine you couldn't deploy it in gale force conditions or anything like that. I mean, the video we were looking at, the conditions seemed relatively calm.
Yeah, well, I mean, when you're working on the the sort of early phases of a project like this, I guess you don't want to destruction test things, but and there would have to be some sort of trade-off between the weight of something and the amount of tether that you need, and how much power cable do you have to put into the tether to get the power down. So it's clearly not going to be a trivial thing to get into commercial production, but it might be, might be interesting for, you can envisage perhaps rock concerts being powered by these things, because the concert's set up outside a winery somewhere, so you just fly 4 of these things to deliver all the energy they need.
Okay, something else to add to the solutions puzzle, and that is solar thermal heating.
Yeah, well, this is particularly about the production of cement, and cement is the second largest contribution of CO2 to the atmosphere caused by human activity. And basically because to make cement you have to heat up limestone rock, and so there's energy goes into the heating of the rock, and then the rock gives off carbon dioxide, and so it produces, any time we use cement, concrete, all of those things, we are directly emitting carbon dioxide to the atmosphere. And we do a lot of building, so it's an important thing. And there have been a number of suggestions over the years for ways and means of producing cements that you can use in building that add less CO2 to the atmosphere. But you've got a number of things to overcome. Lots of teams have worked on cements that can actually absorb carbon dioxide from the atmosphere. So basically you build a building using one of these special cements, and then over time it would absorb CO2 from the atmosphere, which would help to sort of reduce the impact. But what this particular team has done at George Washington University in the US is come up with a what they call their solar thermal electrochemical production process, or STEP process. And it uses solar thermal heating, which is basically mirrors, if you like a solar cooker, or like those solar thermal plants. I think we had some pictures on the last show, didn't we, of the mirrors pointing up towards a big tower. Using that sort of heating to create the heat that's required to run the process. But they use an electrolysis process of the limestone to convert it into lime. And what it does is that by using electrolysis, instead of producing carbon dioxide, it actually produces carbon monoxide as well as oxygen. And that has a number of important advantages. First of all, it doesn't release CO2. The carbon monoxide has a value. It can be used in industry as a feedstock for various things. And they reckon that once it's properly commercialized, you could actually make money from the cement, not just by selling the cement that you've made, but because the value of the spin-off products would be so high. And they also think that it could be used in other areas apart from cement production, but iron and aluminium purification, glass, paper, and sugar production even. Okay. So interesting. And because cement is such a big contributor to humanity's carbon footprint, any process that can help to reduce that is going to be important as we go forward.
Very, very nice. Like the look of that, and we'll follow that one with interest into the future. But that wraps up the solutions segment, and therefore the show for this episode number 26 of the Climate Show. Good to be back, and I hope you enjoyed the show. Remember, it is available in 2 forms, in video and on in audio as well, and you can subscribe to the various streams in iTunes or on Stitcher on your mobile device, and get it in the mix with a whole bunch of other podcasts as well. And as a video form as well, you're welcome to go and check that out also at theclimateshow.com and hot-topic.co.nz.
And remember too that we're always keen to get your feedback. You can leave comments either at Hot Topic or at the Climate Show website. You can get in touch with us on our Twitter feeds, all sorts of things that you can do to get us information. But please let us know what you think. Let us know what you want to hear, people you'd like us to interview. If you want to make mashups with our stuff, please cut and paste and distribute. Let's get the word out.
Indeed. Theclimateshow.com, hot-topic.co.nz, facebook.com/theclimateshow, and twitter.com/theclimateshow. I've been Glenn Williams, and that's been Gareth Reynaldo.
Yeah, I have been, and I still will be the next time we do the Climate Show.
Fingers crossed. We'll see you then.
Cheers, Glenn.
What good is a drop in the ocean? What good is a drop in the